We're going to do our final lesson where we're really definition heavy. So we're going to talk about segment relationships in circles today. We spent the last couple of days doing angle relationships. This is our last one, segment relationships. So we'll get a couple definitions and theorems down. Your chord-chord product theorem basically tells you that if two chords intersect in the interior of a circle, then the product of their segments are equal. Alright, so AE times EB, which is what it tells us here, equals CE times ED. These problems aren't going to be very tricky. So here's an example. It wants us to find the length of x, and then it wants us to find the length of each chord. Alright, well based on what we have, we know that 6 times 4 is going to be x times 8. Solve for x and you get x equals 3. Okay, so we solve for x. We know that the length of ST is going to be 3 plus 8. And I know you guys can do this in your head, but just to kind of drive the point home, where we're getting these numbers, and the length of chord PR is going to be 6 plus 4, which is going to be 10. So looking at a little bit of a different problem, this pulls a theorem that we used several days ago. Archaeologists discovered a fragment of an ancient disk. To calculate its original diameter, they drew a chord AB in its perpendicular bisector PQ. Okay, so based on what we talked about before, guys, if a diameter or a radius intersects with a chord, it is the perpendicular bisector. Okay, so that means this is going to be the diameter. All right, bisector, so those guys are going to be congruent. So I can go ahead and label this as 5 as well. And what I want to find is I want to find the length of PR. So I know that 3 plus x is going to give me that length. Well, based on the previous theorem that we just did, I know that 5 times 5 is going to equal 3x, and I can solve for x, and I end up getting 8.3. Okay, so I have my x here. Now I need to find PR, so the length of PR is going to be 8.3 plus 3, which is 11.3. So this problem is a good little one because it pulls in some previous knowledge that we talked about a few days ago. Alright, so now we're going to do a few definitions that are going to get us to this product theorem. So a secant segment, guys, is basically a segment of a secant. It has at least one endpoint on the circle. Alrighty, so if you look at this here, PM has at least one endpoint on the circle. Okay, that's our secant. And we also have NM. It's a segment of that secant that has one endpoint on the circle. KM, at least one endpoint, and JM, one endpoint on the circle. So just some definitions. That's really going to take us to our theorem. And we also have something called an external secant segment, and it's basically going to be NM and JM are the external because of the fact that they're on the exterior of the circle. Okay, so your secant product theorem, I'm going to skip to this. What this basically tells us is that I can solve for an unknown in the length of these secants, these secant segments, by multiplying the whole length times the outside, because that also equals the whole length times the outside. Alright, so that's what it tells us. If two secants intersect in the exterior, then the product of their lengths of one secant segment and its external equals the length of the next secant segment and its external. So what you guys need to write down for this is whole times outside equals whole times outside. This is the main thing I want you guys to remember for this section. It's going to help us in our next theorem as well. Okay, now be careful, you guys. This is, the whole is this plus this, not this times this, and that's going to be an easy mistake to make. Alright, so let's look at this problem here. I want to find the value of x, I want to find the value of this chord here. And so, I know that whole, what is my whole? It's not 24, it's 10. Okay, and then watch out for this. What is my whole? It is not 5x, it's going to be 5 plus x. Alright, now we just need to follow our formula. Whole times outside, whole times outside equals whole. This is a little uncomfortable. We just got to do our algebra. Whole times outside. Alright, so 40 equals 25 plus 5x. Solve for x, and you end up getting x equals 3. Okay, It's asking us to find the value of x, so we got that. And then we also want to find RQ. So our Q is going to be 5 plus 3, so it's going to be 8. So the main thing to keep in mind here, like I said, is whole times outside, and just be careful you don't multiply, you add it. It might be worth going and writing what the whole length is before you get down to your formula. Okay, this is our final one we'll do. I'm going to follow the same pattern, even though this is a little bit different here that we just said. And then you just have one thing to remember. So a tangent segment is a segment of a tangent, and it has one endpoint on the circle. Okay, so this is, remember your tangent just kisses that circle, just touches it. So this is a segment with one endpoint on the circle. All right, so these two guys are tangent segments. So your secant-tangent product theorem, is basically whole times outside equals tangent squared. Okay, so if a secant and a tangent intersect on in the exterior of a circle, the product of the length of the secant segment and its external segment equal the length of the tangent segment squared. All right, so that's a whole lot of stuff. Basically, guys, whole times outside equals tangent squared. All right, but think about it like we just had. Whole times outside equals, you can think about it like this, whole times outside, and that's going to get you the squared. So if you want to think about it in the same way that you thought about it before, it's going to get you home as well instead of thinking of another formula. Whole times outside, whole times outside. All right, so same thing here. Let's go ahead and write down what our whole is. It's 9. So whole times outside equals whole times outside. And in this case, x equals plus or minus 6, which of course is going to be a positive 6. Alright guys, so we'll go through and talk about this tomorrow as a quick little reminder, and we'll work on this homework in class.